Good day, everyone. This is discussion 3 by Yasser Al-Abdulwahid for Business Statistic 2 for Professor Marion Smith. First, we must understand the problem given to us. Suppose a hypothetical employee starts working in year 1 at a salary of $50,000 a year. Assume each year her salary increases by approximately 5%. What is asked is, create a table that shows her salary for 20 years and create a scatter plot for a salary versus year with the least squares regression line. Find the R-square for these data. What percent of the variation in salary is explained by year? And last but not least, is there a strong linear relationship between year and salary? Based on the problem, here are the things we are asked for. A table that shows the salary for 20 years, scatter plot showing the relationship between the salary and the year, the coefficient of determination R squared, percent of variation in salary explained by year, the quality of relationship between the year and the salary. We are first asked to construct a table showing the salary for 20 years. We know that we are given with the initial salary of $50,000 a year, and we also know that the salary increases by 5% every year. So using this information, we can compute the next salary using the following equation. So where S is equals to salary, N equals to year, and S1 equals to the increases, and here. So for example, to solve for the salary at a year, N equals 2, we know that S1 equals to $50,000. We have the following solution. The salary increases will be $2,500. Therefore, the salary for year 2 is $52,500. So we can then here solve the salaries for the succeeding years using the same formulas. With that, we now have the following table showing the different salaries for every year. Now we will construct a scatter plot for our data. We let x equals year because it's the independent variable, and we let y equals salary because it's the independent variable. X is the independent and y is the dependent variable. We will also use the data from the constructed table. Here is the constructed scatter plot, and the x-axis is the year, while the y-axis shows the salary. As we can see, the two variables from the two variables form an almost linear relationship. We are told to solve for R square, or the coefficient of determination. We can do this using Excel or manual calculation. Using the Excel, we acquire the following answers: that R square equals 0.9846 and R equals to 0.9923. We then try to solve it manually. We know that the equation for correlation coefficient R is this formula. And furthermore, we know that the standard deviation of X is this formula, and the standard deviation of Y is this formula right here. So in order to make things easier, we do the calculation in Excel. We are able to come up with the following table right here. The X is the year and the Y is the salary. The succeeding columns are the necessary computations to solve for the standard deviation and R. We also have the summation, which are highlighted in yellow. These are values we will be using to solve the problem. So substituting the data from the Excel table in the previous slide, we can solve for standard deviation of X and Y by using the equation earlier we have. So the standard deviation of X will be 5.92, and the standard deviation of Y will be 23,672.25. From that, we can now solve for the correlation coefficient R, which is 0.9923. And squaring that value, we can get the coefficient of determination R square, which is 0.9846. And we know that we now know that the coefficient of determination R square is the proportion of the total variation in the dependent variable Y that is explained or accounted by the variation in independent variable X. And in this case, 98.46% of the dependent variable Y, which is the salary, is explained by the independent variable X, which is the year. Finally, we can conclude that there is a strong relationship between the year and the salary because the correlation coefficient is close to 1. Furthermore, the coefficient of determination is close to 100%, which indicates that variations in the salary can be explained by variation in the year. And thank you so much for listening. This is the end of discussion 3. Thank you. Bye-bye.